Hi everyone once again. In the previous session, we did talked about atom and relative atomic mass. Now, in this session, we are going to move forward with the other topic of molecule. So this is the topic here. Regarding the molecule, I will use one analogy here first. Let's say this is a pond. Okay. So in the pond, normally, what is present inside the pond? There is a water. So now, if we are going to extract some of the water from the pond into a tank, let's say this is a tank here, okay, and I'm further going to transfer the water from the tank to another portion here. Let's say a small kind of like a bucket of water, okay. And what I'm going to do, and I'm going to further like, it will transfer that into a, let's say, a bottle of water, okay. So now in this situation number 1 or in number 2, 3 and 4, what did you observe was you observed that quantity changed, that is quantity changed, right? Because over here in pond there is a huge quantity, and in this case there is a huge quantity. In bucket of much smaller as compared to tank and pond, and in bottle of water is very different there. Now from the bottle of water we are going to transfer, like make it a drop of water, let's say a drop of water. And over here also the quantity has changed somehow, but what is the similar thing is the material is same. That is, material is same, right? This is water, this is water, and this is water, this is water, and this is also water, right? Okay, now if we are going to maximize this, we are going to zoom it out, what we will get from this drop of water, we will get thousands and thousands of water molecules, right? So generally we talked about the water as formula is H2O. That means we will get something like this here, O and H. Is that clear? H, 2H and O. And they are joined together by some attractive forces. Now, the point over here is that this is also water, this is water, this is water, this is water, this is water, and this is also water. But the quantity has changed from a huge scale to a one water molecule over here. Now what we are going to do, if we are further going to break this down, what we will get? We will get 2 hydrogen and 1 oxygen. Now is this water? No. Now this is no longer water. Why? Because there is no attractive forces between that. So now we call this as molecule. This particular thing as molecule. Whereas we are not going to call this as molecule. So talking of molecule, it should satisfy 3 important points here. Number 1, that is, it is the smallest particle of an element or compound, right? So let us talk about water in pond. The smallest particle of the water molecule or a compound is this over here, that is the water molecule over here, okay? And it should be capable of independent existence. That means it should be having independent existence, and it should be having similar properties to that of substance. For example, okay, this particular liquid here, this particular water molecule is having similar property to the water present over here. Whereas if you think about this one, it doesn't have the similar property to this one over here because they are in the form of gaseous form. So generally, molecule is smallest particle of an element or a compound, and they are capable of independent existence, and thirdly, they should be having similar properties to the substance. If any kind of like substance which satisfies these 3 important points, we call this as molecules. So now in our life we talked about many kind of like molecules here. For example, O2, CO2, H2O, then NH3, then there is H2, then there is Cl2. Okay, fine. So all these are molecules here. Now, if what we can see from here is that there are two different kind of things over here, right? What do you see is that there are some sort of like molecules which are like made up of two or more different elements here. Whereas there are some elements here, some molecules here which are made up of a similar kind of atom here. For example, in the case of O2, we have like 2O, 2N, 2Cl, and 2H2 here. So we are going to classify that into two parts here. Okay? Let's say O2, N2, H2, and let's say Cl2. And in this case, we're going to write CO2, NH3, and H2O. Okay. Now, when we classify this into two different parts here, what we came to know is that in this side, the atoms are from the same kind of elements here. Because in this, there are two oxygen that is from the same element of oxygen. And over here, this is nitrogen of same element, hydrogen of same element, and this is a chlorine of same element. These kind of molecules here, these kind of molecules, they are referred to as molecules of the element. Okay? These are referred to as molecules of elements. Now talking about this one over here, carbon and oxygen, they are totally different atoms here. Whereas nitrogen and hydrogen, they are all absolutely different. Whereas hydrogen and oxygen, they are totally different. These kind of like molecules are what we used to refer as molecules of a compound. Molecules of compound. Is that clear? I hope you had understood that thing here. Now we will go for molecules of element over here. Okay, so molecules of element. When we talk about molecules of element, we come across a certain kind of point called atomicity. Atomicity. Atomicity is how we should define something like this here. Number of atom present in a molecule. Number of atom present in a molecule. For example, here, let us talk about oxygen here. Oxygen, 2 oxygen, and nitrogen is 2, and hydrogen is 2. Okay, so now if you think about all of this, let's say, how many atoms were involved in that? Oxygen, 2, right? How many nitrogen were involved in N2? 2 nitrogen. How many in hydrogen? 2. So generally, this 2 is what we used to call as atomicity, because 2 oxygen is involved, 2 number of atoms is involved in a molecule, and 2 number of nitrogen is involved in a molecule. That is why these kind of like atomicity is what we used to call as diatomic. Okay, is that clear? Now there are some other elements like phosphorus, which can exist in the form of 4 different kind of like there is an involvement of 4 different atoms there. So these kind of like how many atoms were involved in P4, we used to call this as 4. Atomicity is 4, and they are referred to as tetraatomic. Tetraatomic. Okay. Now let's say, suppose, imagine talking in terms of sulfur. Talking in terms of sulfur. Sulfur normally it constitutes like 8 atoms in that. Understand? So any kind of like molecules which have the presence of more than 4, we used to call this as polyatomic. Polyatomic. So polyatomic means whenever there is an involvement of more than 4 atoms in that, we used to call this as polyatomic. So now here, but I would like to talk about some sort of like exceptions there. For example, in the case of like sodium, that is sodium, and in the case of magnesium, and in the case of iron, and in the case of copper, Cu. All this, they are having an atomicity of 1. Why? That is the question here. Sodium, magnesium, iron, and copper, they are normally regarded as their atomicity as 1. And normally, one atomicity is what we used to call as monoatomic. Monoatomic. Now, why do these 4 elements they have an atomicity of 1? Is that in that case, the large number of sodium or magnesium or iron or copper, large number of sodium are stacked together or present together in a small volume. That is why we call it as monoatomic nature. And in this magnesium also, large number of magnesium are present together in a small volume there. And in iron also, large number of iron molecules are present in a small volume there. I'll write here, large number are present in a small volume. Okay, is that clear? So, in sodium, magnesium, iron, and copper, we used to refer that as monoatomic nature. Why? Because large number of atoms are present together in a small volume. But there are other like monoatomic things like, for example, in the case of carbon. Carbon is also referred to as monoatomic by nature. Monoatomic. Why? Because carbon normally they are like made up of large number of atoms. They come in the form of different kind of forms there. For example, carbon. The example of carbon is this particular chalk is a carbon, and graphite. Then diamond also. Then Buckminster fullerene. Carbon normally they have the ability to make different forms. They have the ability to make different forms. And that different forms comes along with a large number of atoms coming together. Large number of atoms coming together. Large number of atoms coming together. So this is the main reason why we are taking carbon also as monoatomic nature. So, especially in the case of sodium, magnesium, iron, copper, and carbon, we used to take this as monoatomic. But there is one more thing here. That is, in the case of noble gas like helium, argon. These are the 2 examples which we normally used to take in class. Helium and argon, and also neon. They are very stable. They don't have to react with other elements. Is that clear? That is why, for example, in the case of helium, is atomic number 2. That means in the first shell there is a 2 electrons. So it is totally stable there. Helium, argon, and neon are very much stable. So that is why their atomicity is again 1. We used to refer this as monoatomic. So talking in terms of atomicity, monoatomic are like which has an atomicity of 1. There is an involvement of 1 kind of atom. And in the case of diatomic, there are 2 kind of atoms present in a molecule. And in the case of like tetra means 4, poly means more than 4. Is that clear? Now this is about the molecules of the element. Now let us go for the molecules of compound. Okay. So in the case of molecules of compound, let us take an example of water here. Right? Okay, the mass of the hydrogen is always 1, and since there is a presence of 2 kind of hydrogen, we used to take 2 is to the ratio of oxygen here. Oxygen mass is 16, so 2 is to 16. We can cancel it, always comes in the form of 1 is to 8 ratio. This is somehow, molecules of compound is somehow similar to that of law of definite proportion here. And in the case of NH3 here, the hydrogen mass is 14 is to 3. Right? Or you can also write 3 is to 14. Then in the case of CO2, carbon is 12 is to oxygen is 16. 16 2s are 32. 12 is to 32. So this is about the molecules of compound. So now, actually speaking, it is very important for all of you to understand what is the difference between atom and molecules. Atom, for example, in the case of molecules, like they are the smallest particle of the element or a compound which can exist independently, and they have the similar properties to that of the that particular substance. We took the example of water. So this is about the molecules, and we will gradually talk about the other topics of the atom and molecules. Thank you very much all.